Let us discuss about the most probable value and other calculations that are related to errors in measurement. The equations of probability are used to analyze measurements which have been made for comparison with other measurements or with a specified standard. These equations are also used to establish procedures so that required results can be obtained. Since accidental errors follow the laws of probability, these laws can be applied to accidental errors after all mistakes have been removed and all systematic errors have been eliminated or reduced to a minimum. The general laws of probability can be stated as follows. 1. Small errors occur more than large errors, that is, they are more probable. So the probability of small errors occurring in measurements is higher compared to large errors. Large errors occur infrequently and are therefore less probable. So the probability is low for large errors to occur in our measurement. And then finally, positive and negative errors at the same size occur with equal frequency, hence they are equally probable. Supposing that we are given 2 points, let us mark these points as A and B. These points are on a level ground and we are asked, what is the true value of the distance x between A and B? What is the true value? To answer this question, we might go in haste, grab a measuring tape, and proceed to the field and measure the distance AB. So you place the 0 mark of the tape and then you unwind the tape. Say you were able to get the distance 45 meters. But is this measurement of 45 meters indeed the true value of the distance between A and B? Well, not quite. We will not be able to get the true value of the distance between A and B. We will never know what the true value of x is because we are not accessible to the true value. The most that we can do is to get the so-called average of several repeated measurements of the distance x, and then we determine the average and we shall refer to it as the most probable value. A basic assumption of probability is that the most probable value of a group of repeated measurements made under similar conditions is the average. It is the average or the arithmetic mean of all the measurements. The laws of probability presume that many measurements, 10, 100, or more, made under similar conditions will provide us the most probable value. The number of measurements made in surveying, of course, for practicality and for economic reason, is of course lesser than 100. Usually we make 4, 5, 6, or 10 repeated trials done under similar conditions. Okay, so to find the most probable value, let's write down the formula. Let us write down the most probable value most probable value. Let us denote it by x bar. The most probable value MPB or x bar is simply the summation of all the measurements xi divided by n. Alright? So where xi is the ith measurement. So if there are 10 measurements, we add up the values of x1, x2, and so on and so forth up to x sub n. Okay? So n refers to the number of repetitions or trials. Okay? So this is the most probable value of the same quantity with the same condition. No? The condition remains the same from one trial to another. Another measurement related to errors is the residual or the deviation. No? So residual or deviation. The residual or the deviation is simply the difference between each individual measurement. It's the difference between the measurement and the most probable value. And we denote the residual or the deviation by V. So for the ith measurement, the residual for the ith measurement is simply the difference between xi and the most probable value. So you will be getting here a value that is either positive or negative. If you consider this vertical line representing the most probable value x, your xi is either to the right of the most probable value or to the left of the x bar or most probable value. So if this is x1, it could be located to the left, or your x2 would be located to the right of the most probable value. Okay, next is the standard error or standard deviation. The standard error is a measure of the amount of variation in the data. So it determines how the observations are spread out about the mean or the most probable value. The value of the standard deviation is 0 if there is no variation. No? So if you measured a quantity 5 times and you were able to get the values 3.4, 3.4, 3.4, 3.4, and 3.4. Obviously, your x bar here will also be equal to 3.4 and the deviation is 0, no? Because all measurements are equal to 3.4. So there is no deviation, therefore the standard deviation is 0. Okay, but in all likelihood, the standard error or the standard deviation is not equal to 0. So we denote the standard deviation for a sample as letter S. In some books, they use the symbol sigma, but in statistics, it refers to the population standard deviation. Since our measurements are only part of the entire population, then it is more of a sample rather than a population. And the standard deviation is calculated using the formula plus minus the square root of the summation of all the residuals squared divided by n minus 1. Okay, so we know that Vi is the difference between Xi and the most probable value. What you do next is you square this difference for each of the measurements, add them up together, divide it by n minus 1, and then take the square root. That will be the standard deviation. All right? Next is the probable error of a single observation. Probable error of a single observation. Now we denote this by E sub s. And E sub s, using the theory of probability, is equal to plus minus 0.6745 times the standard deviation s, or plus minus 0.6745 times the square root of summation Vi squared all over n minus 1. This indicates the degree of precision which may be expected in any single observation made under the same condition. Then we also have the probable error of the mean. Okay, so this is the probable error we expect for a single observation, while the next one is the probable error for the mean itself. And we denote this by E sub m. And E sub m is plus minus the probable error of a single observation over the square root of n. The probable error of the mean of a number of observations of the same quantity is simply the error of a single observation divided by the square root of the total number of observations. This is the error we can expect of the most probable value. Then finally, we have the error ratio, or sometimes we refer to it as the precision of measurement. How precise is our measurement? The error ratio, or the relative precision, sometimes it is also called relative precision. The relative precision or error ratio is simply equal to the error of the mean, the probable error of the mean, all over the most probable value, or divided by x bar. Please be reminded that these formulas are applicable for same quantity measured under the same conditions, no? Because it is possible for a number of measurements done under different degrees of reliabilities, no? So say the reliability for measurement in trial 1 is different from the reliability or precision of measurement for trial 2. So in that case, our most probable value will be calculated differently. So this is for measurements on a single quantity done under the same degree of precision. So next we'll have a sample problem. We will calculate for the most probable value the residuals up to the error ratio or relative precision.